So we will see, we have got MapReduce, so why do I need pig? Okay, then what are the use cases where pig is used? Some of the use cases in the healthcare domain. Where should I use pig? Where should I not use pig? How to get started with pig? What are the different components in pig? What are the data types in pig? Then we have got in our blog something on the pig UDF, how to create a pig UDF. And then we will have an empty space called as pig versus hive. You have just understood pig, you haven't seen hive. So next week we will be looking at that definition in a proper fashion. So this is what we are going to see today. So the question comes, okay, this is something that we will see on next Saturday. Okay, that is the combiner, partitioner, MapReduce joins, Hadoop data types, your MR testing. Somebody asked me last week about unit testing. So this is the MR unit testing, distributed cache, sequence files, talking about Hadoop counters, etc. So this is what we will see in the next session. So let's ignore this and let's go ahead. So now the question comes, why do I need pig? So if you ask a non-Java programmer, do you know Java? So he's going to ask, what? What are you talking about? So if you look at the development time required for pig, 10 lines of pig statements would be 200 lines of codes in Java. Okay, so that is what is the significance of making something as very small. Okay, plus the biggest advantage of pig is that it has got a lot of inbuilt operators like your join operator, group, filter, sort, etc. So you don't have to write a code for that. So the default operators are always there. So that is what is advantage. So you don't have to learn Java at all. Okay, Abhishek Sawant was saying, are pig, hive do the same job or do they do different? Okay, so what does HDFS understands, Abhishek Sawant? Only MapReduce. So either you can do a traditional MapReduce code, which a Java developer will do, or if you don't know Java, if you like more of scripting, you can start with pig, wherein you will do a scripting approach. And if you are more from the SQL world, you will use Hive. So all three of them do the same thing, but then it is giving you the choice of how to go about doing it. But then there are some limitations, there are some strings attached to it. So like for example in Hive, you can do only structured data. In Pig, you can do both structured and semi-structured data. You can't do unstructured data, whereas in MapReduce, you can do anything. So that is the difference at a very high level, Abhishek. Okay? Hope that makes it clear. And after today's session, I would want you to very seriously look at the examples as well as look at the Hadoop definitive guide for Pig. Thank you. So let me move on. So why was Pig created? When we already had MapReduce, why did you need Pig? So Pig was actually created by Yahoo. So they had a lot of ad hoc work that needed to be done. They wanted it to be done on the client machines. That means they didn't want people to log on to the cluster and do things. So this was their two primary requirements. So Pig was created because you wanted an ad hoc way of creating and executing MapReduce on huge data sets. Okay, and if you're having non-Java programmers, then that is a very big challenge trying to do that. They wanted to do it in a RAD fashion, rapid application development fashion. They didn't have the Java guys. Okay, they had people who knew more of scripting. Okay, so that's why no Java is required, and that's why it was developed by Yahoo. So when I say ad hoc way, what do you mean by ad hoc is, what do you do typically in OLAP? You will have some kind of standard reporting, right? So if your reports are known at the end of a week or at the middle of a week or on every Thursday, you want some reports to be done. So the reports are all standardized. So that is what is typically reporting. But ad hoc is the opposite of reporting. When I don't want to do something, I see that there is a sudden surge in something or there is a need, what happens, and you want to analyze it at that time. That is what is the meaning of ad hoc. Okay, so Hassan had asked me, can you just revise ad hoc? So this is what is the meaning of ad hoc. Okay, that means it is not in a structured way. That means it is not scheduled. It's not like reporting. So this is the reason why Pig was created by Yahoo. So now the question comes, oh, why should I go for pig when I already know MapReduce? So if you're a Java developer, you don't have to do anything. You can stick to the Java development. That is still the best. But then if you look at the number of lines in the code for MapReduce and for pig, you would see how the number of lines would be reduced. And if the number of lines are reduced, of course, the development time would also come down. Okay, and the performance is at par with raw Hadoop. That needs to be taken with a pinch of salt, because MapReduce, see, whenever you type something, you need a compiler which will compile the code into MapReduce also, right? So there is an additional overhead of compiling the pig code into MapReduce, okay, which is not there in a traditional MapReduce. MapReduce is the native language, so it would be faster, whereas there would be an additional overhead in the case of pig. So we need to look at the statement that performance is on par with raw Hadoop. So it is with an asterisk, so you have to be careful with that. So that's the reason why I should go for pig when there is MapReduce. There we go. So let's go for an explanation of what is MapReduce and what is pig. One, MapReduce is a wonderful model for parallelism. The framework ensures that the data is split into different blocks and it is run parallelly. However, it is based on a rigid procedural structure wherein you need to write a mapper, then you can have a combiner, a partitioner, which will, the default partitioner will partition it based on the hash of the key, and then there would be a reducer. Okay, it also gives you a very good opportunity to parallelize algorithm. Okay, and it have a higher level declarative language. So that is what is MapReduce in general. Okay, so what is pig? Pig is actually a data flow language. So you can see over here that it says that it is desirable to have, in fact, I have already raised this. So if you go down to the next slide, just one second, and I'll tell you what I'm talking about. See here, pig is a data flow language. So MapReduce is a high-level declarative language, whereas with pig, it is desirable to have a data flow language, not a high-level declarative language. It should be a data flow language. I've already brought it out, and hopefully this will be changed in the new release. So it is similar to a SQL query where the user specifies what do I need and leaves how to do it to the underlying processing engine. So it is a kind of a data flow language. So this explains to you what is the difference, or why should I go for pig when you already have got MapReduce. Okay, and pig would automatically convert whatever you have written into MapReduce, because HDFS at the end of the day only understands MapReduce. This is clear, guys, as to why should I go for pig? Because you are a non-Java developer, you want to do ad hoc processing, so that's the reason why you are getting into pig. So it's pretty straightforward. Now, where should I use pig? So let me go back to a couple of questions that is coming. Hey, that's good. Thanks, Hassan. So where should I use pig? Like I said, pig is a data flow language. So I'll explain to you. Okay, Sham was asking what is data flow. I'll explain that soon, Sham. So Sampath was saying, so the underlying engine is still MapReduce and pig. Yes. Pig is a ecosystem on top of, if you look at the diagram that I had shown it to you on day one about the Hadoop ecosystems, pig is going to be a layer above your MapReduce. And pig compiler will convert your scripts into MapReduce on the fly. Please remember, there will be no Java code that will be created. It will be converted on the fly and executed, and you would see the output coming up. Okay? So it's a kind of a wrapper. That's correct. It's a kind of a wrapper so that it gives you the ability to write things in a far more simpler way. Okay, Sheikh? Without you having to write explicitly MapReduce. So Sheikh was asking wrapper. That's what it is. So Sagar was saying, so pig is used before MapReduce? No, my dear friend. Remember when did MapReduce come? 2004. Okay, 2003 GFS came, 2004 MapReduce came. Pig is just a layer that was developed which is on top of the existing MapReduce to make life simpler for you. That's all. Okay, fantastic, Sampath, great Sheikh. So hope it is clear, Sagar also. Okay, thank you. So it is not that it has come before, in fact it came after that. So pig is basically a data flow language. I'll explain to you very soon what it is. It's at the top of Hadoop and makes it possible to create complex jobs to process large volumes of data efficiently. So the use cases where I can use pig or where pig would be very suitable is time-sensitive data loads. That means every 2 hours or every 4 hours or every 6 hours I want to do some data load and do some analysis. When you want to do ETL, extract, transform, and load, when you want to take the data from multiple data sources, you want to merge them, you want to pre-process them and generate some output, that's a lovely use case. ETL is done in a very good way using pig. And when you want to do some analytical insight through sampling. So if you want to do anything in the form of sampling, that is ad hoc processing of data to see if there are some patterns that is there that I can see by running some small data sets, so then you could do that with the help of pig. So these are the typical use cases where pig is going to be very useful, folks. Okay. So this is the last slide before we get into some hands-on. Let me go back to my VM, and I hope all of you have logged in. I am simply logging in and I'm coming back to the screen. So where should I not use pig, or where pig is not going to be helpful? When you have got some really nasty data formats or completely unstructured data like your video, audio, or raw human readable text. So in such cases, pig is not going to be useful. Pig is very useful when you have got semi-structured data. Okay, so of course structured data and semi-structured data both can be done with pig. Hassan was saying, sir, but you had said that we can do only analysis, then how come analytics come over here? See, that is a term that people use sometimes interchangeably. Okay, so when I say analytics, okay, analytics is typically using some algorithms, okay, like I said Mahout, like you have got SAS, you have got SPSS, you have got R, so regression analytics. So those are completely analytics domain. So people tend to use analysis and analytics interchangeably, okay. So if you want to do regression analytics and all that, then you'll have to use some third-party data science kind of languages, because basically for analysis. Hope that makes it clear for you. Okay, wonderful. So we were talking about when should I not use pig? See over here, sometime back I said that pig is definitely slower as compared to MapReduce job, because you need a compiler, right? The compiler would need to compile it and then go back and run it. So it is definitely going to be a little bit slower as compared to MapReduce. And when you would like to have more power to optimize your code, that means you don't want to use the default code that is generated. So for Java developers, I hope you will understand the difference between JSP and servlets. Okay, servlets you have to compile it. JSP is auto-compile. For non-Java developers, I am talking about scripting languages like ASP and Java server pages, wherein you write the code and the web server automatically compiles it. So, and it converts it into a Java code. So pig is like that. So it converts your pig scripts into MapReduce and then executes it on the cluster. So if you want more power, then you would want to go back to the underlying layer, because here you don't have a control on the way how the code is optimized. So if you want full-fledged optimizations, then again MapReduce is a good choice. If you want to process if you want to have more power and very fast analysis, then MapReduce is best. If you want to do completely unstructured data, then MapReduce is good. Pig is good for structured and for semi-structured data. Okay? Let me go back to the next slide, no, we are not getting into that now. So I'm not going to go to any right now. So we have seen where not to use pig. There is one definite advantage of pig, is that pig can be executed on your client machine. That means you don't have to be inside the cluster to execute pig. We will be seeing it in a couple of slides from now onwards. I'm just introducing the topic to you right now so that it will be there in your minds. Pig can be executed on your client machines. That's what I wanted to emphasize over here. Okay. So if you look at pig, so again a quick description of what is pig. We have seen it as what it is. It's an open source high-level data flow system. It provides a simple language for queries and data manipulation. The language is called as Pig Latin, which is compiled into MapReduce jobs that is going to be running on Hadoop. Why is it important? Because companies like Google, Yahoo, and Microsoft are collecting huge amount of data sets in the form of clickstreams. Clickstreams means where do you click on a web page once you log into it. looking at your search logs and web crawlers are nothing but the complete set of files, how you are. It's something similar to your click streams. Search logs is nothing but your error logs. So a lot of analysis is happening on these kind of semi-structured data nowadays. So some form of ad hoc processing and analysis of all of this information is required, although there's nothing like reporting. Okay, reporting is typically done on an OLTP data. So that is what is the advantage of PIG, or that is what is PIG, friends. Hope it is clear to all of you. So use cases where PIG is used: one, processing of your web logs, that is your error logs; data processing for your search platforms, if you want to do a search across multiple sets of data; support for ad hoc queries across huge data sets; and if you want to quickly prototype an algorithm for processing large data sets, that is the best use of PIG. You're not trying to look at a reporting kind of a tool, but you're going to do some ad hoc processing and quick prototyping. So the people who typically uses PIG is what is going to be data scientists. It is not going to be reporting folks. Reporting folks typically use Hive because they like SQL. So it is going to be the data scientist who is going to be working with PIG folks. Okay. So how Yahoo is using PIG? So PIG is best suited for a data factory. That means a place where all the data is going to come in. A data factory typically contains pipelines. That means the way how the data is going to flow in. Pipelines bring logs from the Yahoo web servers. There are multiple web servers. Logs are brought into the data factory via the pipelines. That is via some internet mechanism. These logs then undergo some kind of cleaning step where the crawlers, the company internal reviews and clicks are all removed. So remember our healthcare example wherein we said that the customer information needs to be removed. So the same way you remove all of this information and then you give it to the researchers. So researchers wants to quickly write a script to test some theory what they have in mind. So PIG integration with streaming. Streaming means the way how the data is coming live and analyze the data when it is coming in makes it easier for researchers to take any kind of script, let it be a Perl or a Python script, and run it against a huge data set. So this is the way how Yahoo would be using PIG, folks. Okay, so it would be connecting to the data factory. It'll do some cleaning operations and then throw that data to the researchers so that they can do their analysis. This is what is a real life use case, folks. So now let's look at the use case in the healthcare, like what I had mentioned earlier. The problem statement that we had was, how do I de-identify the personal health information of the different people whom I'm having the records? So in another class, we had people, a participant of mine who had a couple of MRIs and who had a couple of different medical records from the physical equipments. Okay, healthcare equipment, and he wanted to analyze that, and that is something that we have also done at Philips also. Philips Healthcare also uses Hadoop to analyze those records and group things in a proper way. So why is healthcare very popular? It is there because you would want to get more and more information about a customer and to see analyze things, but then you have to remove the customer information out of it, right? So the personal, because of privacy, HIPAA compliances, you have to remove the personal health information out of it. So the challenges here is a huge amount of data is flowing into the system daily. So there are multiple data sources from where you have to aggregate the data from. And crunching this huge data and de-identification had its own problems. You have seen it in the map reduce last time, what the problems are, friends. So this is just an abstract diagram to show you how it would work. You would take the database dump in a CSV format and put it into HDFS. How do I put it into HDFS? Minus put or minus copy from local. Then you will read the CSV file from HDFS, like the load what we did right now. You will de-identify columns based on configurations and store that de-identified data back into another CSV file that is there in the output. Okay. Yes, yep. We had gone through this using MapReduce earlier, Hassan. Now I'm showing you how this can be done using your PIG. Okay, and then you will store those de-identified, comma-separated value files back into HDFS. Okay, so just showing you how it could be done using MapReduce and how it is going to be done using PIG, friends. So now, if you look at the weather data, we have already done the weather data in our MapReduce. The same way you can do the weather data with Pig also. And this is what is available for you in your LMS, folks. Okay? So we have got about another 7 minutes to go for a break. So let's look at what all are the very basic Pig programming structures. One, you have got the grunt shell, okay, which is an interactive shell for running Pig commands. It is also possible to run Pig scripts from the grunt shell using exec. So that is what Janardhan was asking me. Can I write everything into a Pig script and then run it? Yes, you can do that. I'm going to show that demo to you. So see over here. So Pig can run the script file that contains the Pig commands, put all of those things into a file, and then simply say Pig and then give the name of the file, which will run it for you. Okay? So if you can either run it outside Pig, or if you're doing it inside grunt shell, you can say exec, that is for execute, and give the name of the file. You can also have Pig running it in an embedded mode within Java. Like the way you run your Java database connectivity, you can run your Pig programs from Java, like the way how you use JDBC to run SQL programs from Java, folks. Okay, so there are 3 ways in which how Pig programs can be executed. So Sagar had a question. I'm putting it in the chat window. He is asking, is MapReduce used instead of Pig where speed matters a lot, right? Exactly. That's bullseye. But then at the end of the day, sometimes it might not be speed. It might be the ability to do it. So if you have got a lot of scripting, folks, then the right way of doing that would be with the help of a Pig script, and wherein the time is not really a constraint. Okay. So for writing MapReduce, also please remember for writing MapReduce, you have to know Java code, right? Yes, we have seen where Pig is not good. Okay, so I'll show you that particular screen real quickly. Before, there it is, where not to use Pig. This is the slide, Sham. Cool. So let me go back to the next set of slides. Okay. Fine, folks. So good. So now, if you want to look at the embedded way, so let me go back. What was the final score? It was 152. That's not a bad score. So using Pig in Java, what is the way? How to do that? I've just Googled it, and see here, run Pig in Java without embedding it. You can write in a script file. There is a programming Pig. There's a full chapter. Okay, so see over here, if I run this particular thing, it'll actually show you how to do that. There is a Java API for this. So there we go. So see over here how you can use your properties file, properties.set, and this is the Pig server which is going to have that code running. See, you can use org.apache.pig server to run Pig scripts from Java programs. Okay. Hey, Sheikh was asking what are the pyramids showing. The pyramid is not really showing anything. The pyramid is just there so that it will show you what are the 3 ways of doing it. Not necessarily one is better than the other. This is a standard pyramid that is there, which we have taken it from the Hadoop wiki, from the Pig wiki. Okay? Cool. So let me go back. Yep, that's they are saying that the script is one way of using it, grunt is another way of using it, and embedded fashion is another way of using it. Okay, it is not trying to say that script is used the most. Okay, you can take it in that way also. If you look at this, embedded is used the least, grunt is used in the middle, and script is what is used in the most. Okay, so it is basically depending upon the interpretation what you're going to have from the diagram. Okay, Sheikh? Perfect. So now let's get down to the next one. So like I said earlier, when I say Pig, Pig is made up of two components. Pig can refer to the Pig Latin language that is used to express the data flows, or Pig can be used to refer to the execution environment wherein it is going to be executed on the cluster, or else it is going to be executed locally in a single JVM. Like we have got three modes of executing MapReduce. You have got a standalone mode, you have got a pseudo-distributed mode, and you have got a fully distributed mode. The same way Pig execution can be done in a Hadoop environment, in a full-fledged Hadoop cluster, that is a pseudo cluster or a multi-node cluster, or it could be done in a single JVM also. So Pig is made up of two components. This is something that I had explained earlier. So when you're using Pig, the reason why Yahoo was using Pig a lot is because it wanted to give the access to a lot of third-party analysts or researchers to access the data that it had, but it did not wanted them to come down into the cluster and do that. So Pig typically resides on the client machine, that is the user machine, and whatever they type, it would get converted into a jar file when you say dump or store. You saw that it did not generate a MapReduce till the time you said dump or store. So only when you say dump, which will show the thing on the screen, or store, when it will store it into a particular file in HDFS, only with dump or store is when the MapReduce code would be generated. Till that time, everything would be a part of the logical plan. Okay, so then once you say dump or store, the jar file is created and the job is executed on the Hadoop cluster. So, and then if it is dump, it will show the results back on the screen. If it is store, it will store it in the Hadoop cluster. So the beauty here is that you don't have to install anything on your Hadoop cluster. Okay, so that is what is the advantage of your Pig execution on the client side. Hope it is clear for everybody, folks. So now when we say Pig Latin programs, what is it? It is made up of a series of operations or transformations that you apply to the input data so that you can produce some outputs. Pig actually turns all of those transformations, whatever you have written, into a series of MapReduce jobs. Okay? So Janardhan had a question on user's machine of Pig. Hadoop installation is mandatory, or the Hadoop library or jar file would suffice? Janardhan, on the client machine, you do not need Hadoop at all. Okay. Hadoop client was needed when we were running MapReduce, because you have to say Hadoop jar, whereas over here only the library files would be needed. Janardhan, you don't need the complete Hadoop cluster, Hadoop setup. Okay, one of you had asked me about this earlier also, friend, and that's what I had mentioned. So the same thing, I'm mentioning it to you too, Janardhan. Fantastic. So this is what happens in a Pig Latin program. So this is the last slide before we take a break. So there are four basic types of data model. You have got something called as an atom, which is an individual value. You have got something called as a tuple, which is nothing but a bracket which will contain some ordered list of values. You can have a bag, which is a collection of this ordered values, and you can have a map, which is a key value pair. So if you look at the documentation, if you look at the Pig reference module, you would see right on the top what all are the various data types that it has. So you can see here that Pig has got types wherein there would be a field is a piece of data. That's what is called as an atom. A tuple is an ordered list of fields. A bag is a collection of tuples, and a map is a key value pair, folks. Okay. Hussain was asking about a pictorial depiction. You would actually see that in our example. So when you did a dump of our group, let me show you a pictorial depiction of it. Let me go down to the Cloudera. We did a MapReduce example, right? So if you scroll up a little bit, let me scroll up. Okay. So what you see over here, this is what is a tuple. You have seen bag earlier also. This is what is a bag. So don't you see within a tuple you will have curly braces? A curly braces having individual tuples separated by comma. That is what is a bag. Whereas an individual car is what is called as an atom. Okay. So since you have already run this example, it is the simplest way of working with it, friend. Hope it is clear what all are these four basic types, Hassan. Okay.